Hello and welcome to the next video on trigonometry. So in this video we're finally going to be getting into the whole purpose of trigonometry and learning some of the most important concepts you need to know for the rest of trigonometry. So as mentioned in the first video on trigonometry, trigonometry is the study of triangles, specifically the study of right triangles. In more advanced trigonometry classes, you will see how even non-right triangles can be related to right triangles. So the whole purpose here is understanding right triangles, and that is the types of triangles we will be focusing on for the rest of these video lessons. So if you remember, a right triangle is a triangle where one of the angles is 90 degrees. That is always a known fact. Now, there are two other angles here. Let's call these two angles alpha and beta. If you remember, we like to use Greek letters to represent angles, unknown angles. So alpha and beta can be really any angle. And then let's call these sides here A, B, and C. Okay, so this is a right triangle. Notice one of the angles is 90. Two of the angles can really be any other angles as long as they're less than 90 degrees. And A, B, and C are the sides of the triangle. However, C is a very special side because it is the only side that has a 90-degree angle opposite to it. And this here is called the hypotenuse. And the hypotenuse only shows up in a right triangle. So let's talk about the relationships that we can find within a right triangle. So first, let's think about it. With the two angles alpha and beta, is there something that we know has to be true that relates alpha and beta together? And yes, we do. So we know that all angles in a triangle have to add up to be 180 degrees. However, since one of those angles is known to be 90 degrees, that means alpha plus beta has to be equal to 90 degrees. And if you remember from geometry, alpha and beta, those two angles are complementary angles. Okay, so that is what relates the two angles alpha and beta together. There's really no need to bring in the other 90 degree because, 90 plus 90 is 180. So alpha and beta are really the only two important angles here. Now, how about the sides, A, B, and C? Is there something that we know that will relate A, B, and C together? And yes, there is a known relationship between all the sides of a right triangle, and that is called the Pythagoras theorem. And what that is that the length of side A squared plus the length of side B squared is equal to the length of side C squared as well. And there we have it. These are the two relationships that show, first of all, the relationship between the angles, and second of all, the relationship between the sides of a right triangle. Now, let's go back to this right triangle, and let's say that we know angle alpha, okay? So alpha has three sides that are related to it. So the first one we're going to look at is this side over here, which I'm going to highlight in green. This is what we call the opposite side, okay? So this is the side that's opposite angle alpha, okay? Now this side here, which I'm drawing in red, this angle is what we call the adjacent side to angle alpha. Adjacent just means next to. So it is the angle that is right next to the angle alpha. And the side here, which I'm going to draw in blue, this here is, as we said before, is called the hypotenuse. The hypotenuse is the side of a right triangle that's opposite the 90-degree angle. Okay? So what we did before is we found the relationship between all angles of a right triangle. And we also talked about the relationship between all the sides of a right triangle. But what we want to do now is figure out what is the relationship between the angles and the sides of a right triangle. Again, there technically is the other angle beta, but beta, again, is just the complementary angle to alpha. So we don't really have to worry about it too much, and if we do, it's very easy to calculate. But let's just focus on angle alpha and the three sides associated to it. So trigonometry focuses a lot on ratios. So if we see here three sides and we want to create a ratio between two sides, how many possible combinations can we create of the three sides? So let's think about that. So we have the opposite and the hypotenuse sides. There's one ratio we can create. We can always find the ratio between the opposite side and the hypotenuse of a right triangle. We can also find the relationship or the ratio between the adjacent and the hypotenuse. We can also find, how about the opposite over the adjacent? Now you may think those are all possible ways in which we can actually find ratios of two sides given the three sides of a right triangle. But this is actually not it. There are technically three others. And those would be the reciprocals. You can also find the hypotenuse over the opposite side. You could also find the hypotenuse over the adjacent side. And you could also find the ratio of the adjacent side to the opposite side. Now you may be asking yourself, okay, how do these ratios relate to the angle alpha? Well, there is something called trigonometric functions. If you remember what a function is, you have an input and then you have an output. You plug something in and you get something out. With trigonometric functions, the input is the angle and the output is the ratio of the two sides related to that angle. So, the first trigonometric function is sine. It's spelled sine, but the function you really write as sin, like that. But where do you put the input? So technically, this is a function where you say sine of the angle. So the solution to this trigonometric function is the ratio of the opposite to the hypotenuse. So you don't have to put parentheses. Sometimes it is important to put them. Other times it's not that important. But this here is a trig function called sine, where the input is alpha and the output is the ratio of the opposite side to the hypotenuse of that right triangle. The other trig function that we have is called cosine. And we write that as cosine, like COS. And then what you plug into the function is the angle. So remember, these are the trig functions. These are what you're going to plug the angle into. So it just so happens that cosine of the angle alpha is going to give us the ratio of the adjacent to the hypotenuse of the right triangle. And the last main trig function that we have here is tangent. And tangent you write as tan of alpha. Again, this is a function. You have to input something. And what you input into trig functions is an angle. And it just so happens that the tangent of angle alpha is the ratio of the opposite to the adjacent side of the triangle, of the right triangle. So we talked about here the reciprocal ratios. These technically also have functions as well. And these are called the reciprocal trig functions. Okay? So, the reciprocal of sine. Let's go ahead and do this in a different color. 1 over sine of alpha. This here is equal to now the hypotenuse over the opposite side. However, this does have a trig function that is reserved for it. And the reciprocal of sine is called cosecant, which you write as CSC of alpha. So cosecant of alpha is equal to the hypotenuse over the opposite. Notice it is just the reciprocal of sine of that angle. Now, the reciprocal of cosine, 1 over cosine alpha, this also has a trig function reserved for it, and that is called secant. And the way that you write this function is SEC alpha. Again, I'm putting the alpha here because you're plugging in alpha into the trig function. So secant alpha is just the reciprocal of cosine. It's going to be hypotenuse over adjacent instead. And last but not least, what about the reciprocal of tangent? This, again, has a trig function reserved for it, and this is called cotangent. And the way that we write this is COT of alpha. So you write this as COT of alpha. And this is the reciprocal of tangent. It's going to be adjacent over opposite. Okay? So these are the 6 trigonometric functions you need to know. In reality, you only need to know 3. You only need to know sine, cosine, and tangent, because those are the main ratios. However, the reciprocals is very easy. You just flip the denominator and numerator. But that also does have a name. What most people get confused is they confuse sine with secant and cosine with cosecant. They always forget which is the reciprocal of which. The way I always remember is to switch it. The reciprocal of sine is not secant, it's cosecant. And the reciprocal of cosine is not cosecant, it is secant. You see, so if you want to find the reciprocal, just drop the co or add the co. You do the opposite, kind of. So that should hopefully be an easier way to memorize these ratios. So put some time into memorizing the trig functions, their names, and what they represent. Let's take a look at a very famous right triangle, the 3, 4, 5 triangle, also called the Pythagoras triangle. So let's say we're looking at angle theta here in this triangle. So let's go ahead and find all 6 trig functions of angle theta. Okay? So let's do the first one here. Sine theta. Sine of theta. Technically, this is not multiplying. This does not mean sine times theta. This means sine of theta. The input is angle theta, and the output is going to be the ratio of 2 sides. So if you remember, sine is the ratio of the opposite side to the hypotenuse. So sine of theta is going to be 3 over 5. Now, the next trig function would be cosine theta. So cosine theta means cosine of angle theta. So that means I want to find the ratio of the adjacent to the hypotenuse of angle theta. So that would be 4/5. Next, we do tangent theta. Again, tangent of angle theta. The solution to this is the ratio of the opposite to the adjacent side. So tangent theta would be 3/4. Now, the other 6 trig functions are super easy because all you need to do is find the reciprocal of these 3. So let's say we want to find the reciprocal of sine. Well, the reciprocal of sine is cosecant, and that would just be 5/3. The reciprocal of cosine is secant, and that would be 5/4. And last but not least, the reciprocal of tangent is cotangent, and that is 4/3. And that is the solution to this problem. I did not mention this before, but an easy way to remember sine, cosine, and tangent, if you haven't heard of this before, is SOHCAHTOA. This is an easy mnemonic device to help you memorize what sine, cosine, and tangent are. So, SOHCAHTOA, which sounds like a chant, goes as follows. Sine of an angle is the opposite over the hypotenuse. Cosine of an angle is the adjacent over the hypotenuse of an angle. And tangent of an angle is the opposite over the adjacent sides of the triangle. So if you know what sine, cosine, and tangent are, you will automatically know what cosecant, secant, and cotangent are. So to wrap up this video, let's do this last problem here. Find all 6 trig functions of the angle theta. So if you see here, we have our angle theta. You want to find all 6 trig functions, which if you remember are sine, cosine, tangent, cosecant, secant, and cotangent. You want to find all 6 of these to the angle theta. So pause this video, try to do this problem on your own, and when you come back, the answers will be shown in a few seconds. And there you have it. These are all 6 trig functions to the angle theta. So again, what you're doing with the trig function is you are inputting the angle, and the solution to that function is the ratio of 2 of the sides. Now, again, because we have 3 sides, there are 6 possible combinations of 2 sides that we can come up with. And these each have their own trig function. This may seem a little redundant at the moment, but you will see in future videos why this is so important to know. So I will see you in the next video. Bye.